Okay guys, now we are looking at questions. The first question that we shall look at is this one. As you can see, let me get this. Well, yes. So here we are. We are looking at this question. Figure 9.1 shows an electric circuit. It is source voltage is 9. There is a resistor here, 4 ohms. Then there are these two which are parallel. The first question is calculate the total resistance in the circuit. That's good. So let me read through the circuit here. Actually, sometimes you might want to change the orientation so that, okay, there are times when students get like confused when they try to determine what is going on, but I'm going to simplify the circuit. We are going to do that together. What we see is the 3 ohms and the 2 ohms resistor, they are parallel. So what do we do? Remember, total resistance of what? Of 3 ohms and 2 ohms. Am I required to do this? No. Why am I doing it? Because I don't want to get lost. So it's product over sum, right? Product over sum. Product over sum. We say R1 times R2 divided by R1 plus R2. That's our equivalent resistance. But for this, there is 3 and 2, so it's 2 times 3 divided by 3 plus 2. This is 6 divided by 5. The answer here is, let me compute this. 6 divided by 5 is 1.2. So now I have combined 3 and 2. What is going on with this? Do we really have time to play with this kind of thing? No, we don't. Right? That's 2 at 2 ohms. What is going on? I really don't like what I see here. I don't like it at all. So that's 2 ohms. So I'm going to redraw my circuit like this, right? Like this. It makes my life much easier. Everybody's lives will be much easier. Then what do we have here? The resistance here is a combined resistance of the two resistors, which are parallel 1.2, and then we have 4 ohms here. Now this is 9 volts, right? So 1.2 plus, because now they are in series, there is only one path from here all the way through to the other side. Yeah, that's it. So RT this time is just in series, 1.2 plus 4. RT is equal to 5.2 ohms. So that's the answer. That's the answer that you get 2 marks for. And then the next question is the current produced by the power source. What are we going to use? Ohm's law. Ohm's law, V is equal to IR. And remember, we are looking at the total current produced by the source. Is the current produced by, let me just write, what am I doing? It's supposed to be current total, therefore we are going to use the total resistance, and we are going to use the EMF, or should I just say V total is the EMF though, right? So if we change the subject of the formula, we have I is equal to V over R. And what do we get? It's 9 divided by 5.2. What is the answer? 9 divided by 5.2. So you get something like 1.7307. That's it. But remember, it has to be 2 or 3 significant figures. So we'll make it 2 significant figures, 1.7 amps. This is the what? The current produced by the power source. Now let's look at the next question. The next question. Okay, we can go to the next page, this side too. Yes. Remember, I read through the circuit to look like this, right? There was 4 ohms here, 4 ohms, and we had 1.2 ohms here, and it's ohms, right? And we had 9 it's just 9 volts, right? Then it can be simplified further, and we usually like to work with circuits like this. So I'm going to combine these two. We did that anyway, and that was 5.2. So when you are calculating the total current, a circuit like this will truly help. So, but now the second question is asking for the voltage across the 3 ohms resistor. How many marks is that? Determine the voltage across the 3 ohms resistor. Oh, it's not really easy. Okay, so we have 9 volts. So this is 9 volts, right? And this is 4 ohms. This is 1.2 ohms. Okay, let us do this. Let us do this because we want to make things okay. The first thing that we need to do really here is, so this paper is for triple science for last year 2022. So the total current, let me write IT is equal to 1.7307, right? So this is the total current. So that total current passes here, which is 1.7307 amps. So using Ohm's law, V is equal to IR. It's for which voltage? for resistor with 4 ohms resistor, 4 ohms resistor, 4 ohms resistor. Usually the way I always ask my student to do is, because they are trying to find the voltage here for the 4 ohms resistor, I tell them to put their finger at this point on this resistor, right? So they are going to use the voltage here, they're going to use the current through this resistor, and they are going to use the resistance of this resistor, because there are a lot of voltages and currents here, right? And resistors. So I don't want them mixing things up. So the current through this resistor, as we can see from the question, we see that all the current passes here, it branches here, right? So the current is 1.7307 times R, that is 4. So now we can say 1.7307 times 4. What do we get? This is equivalent to 6.228. So the voltage will be across 4 ohms resistor. I'll just write 4 simplicity. Then we have, let me do it 2 significant figures, right? Yeah, 6.9 volts. But we're asked to find the resistance for the 3 ohms resistor here, as you can see from the question here. So what do we know? From 9 volts, and then the charge passing through 4 ohms, all the charges are going to pass here, so it will have a potential drop of 6.9, right? Minus 9, that is 2.0772. So the voltage which is available for these 2 resistors, that is going to be shared, if it has to be shared. Okay, so voltage left is equal to 2.1 volts. And what do we say? Each charge will have a potential drop of 6.9. Each and every charge on passing here, it will have 2.1 volts. The charge passing through this point, 3 ohms, will have 2.1. The charge passing through 2 ohms will have 2.1. So that's it. That's 2.1 volts. So what we have here, determine the voltage across 3 ohms resistor. Across 3 ohms resistor will be 2.1. This is the voltage that is available. Okay, C, we are to calculate the energy transferred by the power source. Power is IV. Power is IV. Electric power, my friends. Electric power is, so where are we now? Electric power is equivalent to P is equal to IV, right? So power is equal to IV. That's the power. And we are asked to find the energy. Okay, I was just too fast. I thought I should be using this equation, but let's start with E. We have to find E. It's a question mark. Then we have time of 180 seconds. And what else do we have? What else do we have? We have current. Current is of the power source, remember. What value was that? I think that was 1.7307. I don't want to round it to two significant figures yet. And what else do we have? V is equal to 9. Energy is this. Okay, power is equal to energy. So what is happening now? Oh my God. What happened? What just happened? My screen just went blank. Okay, I'll continue from this point. Okay guys, we are back. So power is energy per unit time. Oh, I think there is a problem here. Anyway, it will be fixed. Power is equal to energy over time, right? So let's do this now. Remember we have to find energy. So from this equation, energy is equal to power times time, and then power, this equation of course. So writing down your data actually helps you to figure things out quickly. So power is equal to IV, that is power, and then times time. So what do we have? 1.7307 times 9 times 180. Let me compute this first. Times 9 times 180 seconds. So the energy is 2804 joules. That's our energy, guys. So this is the answer. So if you understand this, imagine from an exam you will be having 2, 4, 6, 8 marks. 8 marks. So it's very important to understand everything. Okay, let's go and find another question. Let's find another question. Well, this question is from 2021 exam. So B, it reads figure 8.1 shows an electric circuit. Resistors X and Y are identical. That means everything else is the same. Everything is the same about them, okay? Particularly the resistance. Then we are told that V1, which is the EMF, is 12.0 volts, and V2, which is the potential difference across resistor 24, is 9.0 volts. The switch S is closed. Now the current can flow. Determine the ammeter reading. The ammeter reading. So where do we start? This is where we start. So we are told V2 is equal to 24. See, it has started. 24 ohms. Then the oh, what am I doing? I'm tired. So V2 we are told is 9.0 0 volts. Then its resistance is 24 ohms. Using the Ohm's law, we are to determine current through the resistor. I'll call it R2 because the voltage is V2, right? So what we have here is, we notice that the current that passes at 24 ohms resistor is actually the total current, but we don't have the total resistance yet to calculate the total current. Rather, we opt to use this resistor because we know that all the current will pass here, so no problem at all. So using Ohm's law, V is equal to IR, then we have I is equal to V over R. What happened to my R then? So V is 9.0 divided by 24. Let's quickly do that and see what we get. 9 divided by 24, we get 0.374 amps. That is I2, and I2 is equivalent to the I total, which is the current read by the ammeter. So it is 0.375. It's actually 5 amps, right? And that's it. And now with this, we now have the current, the total current. So the following question, Google. Yes. So the resistance of resistor X. Okay. Where do we start? Let me redraw the... Oh, I shouldn't have done this. Just this, right? And this is what we have. This is X, right? And we have Y here. And then we have 24 here. 24 ohms. And we have an ammeter here, and this is what we have. Okay, what we know is we have 9 volts here. We have how many volts? It's actually 12 there. This is 12, guys, 12 volts, and this is 9 volts. So with this, what we know is now these 2 9 are taken away from 12. We have 12 minus 9 is 3 volts. We have 3 volts, right? These are parallel, whether they were identical or not. The voltage across them, let me use this one. The voltage across them, good God, the voltage across them, this one is not even, it's not black to my liking, really. What is going on? Let's choose 6 and see. Yeah, much better. So they both have 3 volts. 3 volts. The idea that they have the same resistance is going to help us in terms of current. Remember, the total current IT is 0.375, right? 0.375. Oh, I don't think you can see this. 0.375. amps, right? So because we have two branches here, and remember here the current is 0.375, so the current is going to split when it gets here, and it's going to split equally because the resistance are of the same magnitude. There is no less resistive part. The parts are of the same resistance. So what is going to happen is the current will be split equally. So the current for X will be 0.375 divided by 2. What do we get? We get 0.1875. I'm not rounding off because I'm still going to use this value, and I'm not asked to find current. We are looking for resistance. So from Ohm's law, this is what we have. We are to find resistance. So resistance for what? For X resist. So I'm going to put X across here to show that we should use everything at X point X, which is the resistor here. So the resistor X will be calculated like this. So if we rearrange it, it will be like this. With this now, let me use this space. Vx is the voltage across resistor X. That is 3 volts, right? Divided by current passing through resistor X. That is 0.1875. Yes, I think you can now appreciate that you need to understand these questions. There are many ways of solving this question actually. 3 divided by 0.1825. Is it 25? See, it wasn't 25. It's actually 75. 75. We have to always cross check. So the answer Rx is actually 16 ohms. So this is the answer, guys. 16 ohms. As you can see, the questions are a little more complicated. You need deep understanding. This is the final exam, remember? 2021. Yes, 2021. So this is 2 marks, this is 3 marks, this is 5 marks. 5, and then there is 2 marks for the power dissipated in the 24 ohms resistor. Okay, let's find a new page. 24 ohms resistor. Power is equal to IV. So power at 24 ohms resistor. I like doing this because I cannot put my finger at the resistor of 24 ohms. So to remind myself, I'm writing 24 so that you also follow, right? I'm going to use the current passing through the 24 ohms resistor. I'm going to use the voltage across the 24 ohms resistor. As you can see, we have calculated the resistor for X. There is a resistance for, there is resistance for Y. There is resistance for this other resistor, which is 24, and the voltages across. So you might think things are complicated, but if you just follow the approach that I'm using, you'll find that your life will be much more easier. So as for current, is the total current actually, because the current that has split has recombined, remember, times V, which is the voltage across the 24 ohms resistor. We were given that the potential difference as 9.0. So let us calculate 9 times 0.375. The answer is 3.7. Oh no, what am I doing? If you compute this, you get 3.375 watts. And remember, we have to write our answer to 2 or 3 significant. If it's not exact, but this one is exact, it's okay. But if you want to stick with 3 significant figures, it could be 0.38 watts. But for this one, it's exact. Remember, the unit for power is watts. So that's it. I think we have, as you can see, the questions. We haven't found a question which is what do you call series circuit? It's always parallel, because they want the questions which might be called a little bit confusing. This is for 2021. I'm trying to find the last question. The last question will do. So these are the questions. These are the questions, exam questions. And I'm going to send all these questions to you guys. Oh, we are like 2020, we had this one. Let's see, but there has to be a trick thing that will make it look difficult. So new page. Well, the first question states the purpose of the ammeter in this circuit. To measure current. To measure what? Current. To measure current. That's what it is for. So the reading of V1 is 6 volts, 6.0 volts. Determine the reading of the ammeter. Yes, you can see they like coming in directly. Were we given there is no EMF? Okay, that's okay. What we should be thinking of here. Okay, let me redraw the circuit so that I can show you what is happening. So this is my circuit. This is 2 ohms. This is 4 ohms. This is let me use red here for voltage. What am I doing? We are given V1 as 6 volts. Okay, because it is given as 6 volts, so each charge uses energy of 6 joules. So if it uses 6 joules of energy here, like each charge, therefore here it will use half of that energy, because this is 4, this is half of 4. So the energy here will be half. The voltage across will be half. That is 3 volts. So when you combine them, you get what? 9 volts. That, remember, in series, V is equal to V1 plus V2. So what do we have here is 9 volts, right? 9 volts. As you can see, the question asks us to find the ammeter reading. I think I might have gone a bit far. I think it wasn't necessary really, but it's okay, because we could say I is equal to V over R. So this is the total current, total voltage from the source, total resistance. Then it is 9 divided by 6. Because really, if you now know what is happening, things will be easy. The total resistance, you add them. So, but I didn't notice that I could use the easier one, that I think, which I think most of you will be happy to use. So we have to find I is equal to V over R. So what do we see across this? Okay, we're asked to find the ammeter reading. That's okay. Across this, now we are going to work on this one. The current that we find here is the total current, because there is only one part. So 6 we are given and 4 is there, so it's 6 over 4, which will be like 3 divided by 2. Let me compute that first. 3 divided by 2. So the current will be 1.5 amps. Even if you use this one, you'll still get 1.5 amp. So if you understand what is going on, things will be much easier for you. So the following question, we are to determine the voltage V2, this one. So really, the way I did it, I think I did it, it could be more complex for those who don't understand yet what is going on. So using Ohm's law will be the easiest way of doing it, but I've already written the answer. Remember, it's 3 volts, because if this one is 6, this one will be 3. So, but we can use this for 2 ohms resistor, for 2 ohms resistor, for 2 ohms resistor, right? That's V2, right? So V2 is equal the current passing through this resistor. The current is the same at all points, so it's 1.5. Then resistor 2 is 2 ohms. So if we multiply, we should get 3. So that's it. 3 volts. V2 is 3 volts. So that's it. Now the next question is calculate the total resistance. You see, it's 1 marker, because really that's R1 plus R2, which is 4 plus 2, right? Is 6 ohms. So that's it. Let's see. And then there's this one. Yeah, I knew it. So what is the question now here? The 4 ohms and the 2 ohms resistors are now connected in parallel as shown in figure 10.2. Okay. The electromotive force of the power source remain unchanged. State and explain the effect that this arrangement has on the ammeter reading. Okay, the ammeter reading, remember, it was 1.5, because I was 1.5. Now when they are in series, for this one, remember the total resistance was 6. For this one, it will be much less than this. Actually, it will be less than 2. Let's quickly calculate it. Sometimes you just have to calculate. But the effect, the ammeter reading will go up. Ammeter reading will go up. Let's see why. RT is equal to divided by 8. What do we get? 12 divided by 8. The total resistance is 1.5. Total resistance is 1.5. And the power source was 9 volts, right? So V is equal to IR. I is equal to V over R. Oh, what's going on? That is 9 divided by 1.5. So let's say 9 divided by 1.5. So that's 6 amps. From 1.5 to 6 amps. So the reading will go up. Explanation is that when the resistors are in parallel, the effective resistance becomes less. It becomes less. The effective resistance for these two in series is 6. When they are in parallel, is 1.5. So the total resistance becomes less. Even this, if this 4 ohms was to be 400 ohms, still the total resistance will be less than 2. Yeah, the product of a sum. So that's it. Any other? Okay. We are to calculate total resistance, guys, but I've already done it right here. The total resistance product of a sum, and that is 1.5. Then the next question here is we are asked to state 2 factors that affect the resistance of a conductor. The first one is the length of the conductor. The second one is the thickness of the conductor. Or maybe you can state temperature. Yeah. So you see, you have to have a deep understanding. The problem with most students, when they solve past exam papers, they think they've covered everything. If you look at these 2 questions, 2 papers that we've done, none of them had this. It's not every time they ask such a question, but the time they do and you don't understand, you're gonna lose marks. So make sure you understand your notes. And in these videos, actually, I will be covering everything. So you are having watched them, you know that everything have been covered, right? I think we should end here. Thank you, guys. We'll continue with problems solving.